Okay, today's lesson is 2.1 in your textbook. It's called the Remainder Theorem, although we're not learning the Remainder Theorem today. Really what you're going to learn today is how to do long division with a polynomial function and a linear divisor. Okay, so let's get started. So long division is something that you did learn in grade school along the way. I'm just going to refresh your memory with the process. If you remember it, great. If you don't, then just let's follow along here. So if we want to divide 8 into 125, we write it like this. And we ask ourselves, how many times does 8 go into 1? And you would say no times 0. So we would normally not put a 0 in the front of a number. So we're just going to move on and say how many times does 8 go into 12? And that would be 1. 8 times 1 is 8, so that's where I'm putting that down there. And then I'm going to subtract. So 12 minus 8 is 4. Then I'm going to bring down the 5. This now becomes 45. And I ask myself, how many times does 8 go into 45? And that is what? 8 times 6 is 48. So 8 times 5 is 40. 8 times 5 is 40. Do the subtraction again. I get 5 as my remainder. So 8 goes into 125 15 times with a remainder of 5. All right. So you go ahead and try it, please. Do A and B and C and just pause the video and see how you do. Okay, so 3 into 456. 3 goes into 4 one time. Not much room here. Bring down the 5. 3 goes into 15 5 times. That's 15. And 0. Bring down the 6. 3 goes into 6 2 times. 2 times 6 is 6. I didn't really need the 0 there. And we have a remainder of 0. We normally don't write remainder 0, but I'll just put it here for now. 6 into 9,041. 6 goes into 9 one time. 6 times 1 is 6. Subtract. Bring down the 0. 6 goes into 35 times. 6 times 5 is 30. I have 0 here. Bring down the 4. 6 goes into 4 no times, so I put a 0 there. Wouldn't put it in the front over here, but I put it in the middle of the number. And then I'll have to bring down that 1, and 6 then goes into 41, 6 times? With a remainder of 5. Let's do the last one. 7 goes into 3,435. Let's see, 7 goes into 3 no times. 7 goes into 34 4 times. 7 times 4 is 28. Subtract, we get 6. Bring down the 3. 7 into 63 goes in 9 times. 9 times 7 is 63. So we have a remainder of 0. Bring down that last 5. And 7 goes into 5 0 times with a remainder that's down here of 5. You can check your answer. So what we would do for something like this is we could check our answer by taking 8 times 15 and adding 5 to it. Okay? So we have a way of checking our answers. So this is long division. So let's go over some of the vocabulary around the terminology. So this is, if I'm dividing 125 by 8, 8 is the divisor. The number that you're dividing into is the dividend. The quotient is your answer, and the remainder is the remainder, of course. So we're going to use all those terms. Okay. Now, I just refreshed your memory with dividing, doing long division, because we are going to use that same process to divide polynomials now. So we're just going to, it's a process, and we're just going to do it one step at a time. So what we're going to do is we're going to take x minus 2, which is what we're dividing by, and we're going to divide that into our dividend, which is 2x cubed minus 3x squared minus x plus 2. Okay, so that's a 3. Let's just make that pretty clear. So the very first thing you want to do is you want to make sure that your terms are all lined up in descending order of power, highest to lowest. And if you have two of the same, you want to combine them. So we're going to start by asking ourselves this. We're going to look at the x here, and we're going to ask ourselves, what do I have to multiply x by to get 2x cubed? Or what is 2x cubed divided by x? Either way you look at it, you know that the answer is 2x squared times x is 2x cubed. So let me just put a blue up here. So oopsie, I thought I changed that to blue. I guess I didn't. 2x, there, I'll do purple. 2x squared here. So once I have figured that out, what I do is I take that 2x squared and I multiply it by x, and then I multiply it by the minus 2, and I put it down here. So we're always working in groups of 2. So I'll make that one green. So this is going to be 2x squared times x, which is 2x cubed, and it should match because that's what we came up with here, right? Was the number that 2x cubed divided by x was. And then when we multiply it, we should get the 2x cubed back. So then we multiply 2x squared by minus 2. So that's minus 4x squared. Okay? Then we do our subtraction just like we did with the numbers. This should cancel. This should be 0. And don't forget, minus 3 minus minus 4 is actually x squared. Positive x. So x squared, then I'm going to bring down the minus x because we're always working with two terms. And then the process repeats itself. So now I'm going to ask myself, what do I have to multiply x by to get x squared? And the answer, of course, is x. So I'm going to put plus x up here. So x times x is x squared. Very good. So now I'm going to multiply both of them. So x times x is x squared. X times negative 2 is negative 2x. Do my subtraction again. We should have 0 here. And when I take minus x minus minus 2x, I really get minus x plus 2x, which is, again, x. Oopsie. So this is x. Bring down the positive 2 because we're always working with 2's. And again, the process starts all over. What do I have to multiply x by to get x? Well, that's easy. 1, positive 1. And so I'm going to end up here with 1 times x, which should be x, and 1 times negative 2, which is, of course, negative 2. Do my last subtraction here. 2 minus minus 2 is 4. Once I get down to a whole number here, there is nothing that I can multiply x by that's a polynomial that will give me a 4. So I know that I am done. This is my remainder. So remainder 4. This is my quotient up here. This is my remainder. This is actually my answer. So what we're going to do is we're going to go to the next page. We're going to learn about quotient form and corresponding form, and then we're going to come back and actually put this answer in the appropriate form. So just hang on for a second. So once you're finished dividing a polynomial function, you get an answer. So your answer can be given in a couple of ways. This right here, this first box, is actually what we call quotient form. And the second one is the corresponding statement. So your textbook's going to ask you to give it in one or both of these forms. So this is called the corresponding statement. So I'm just going to unpack this for a second, but first I'm going to give you an example here. just with numbers. So if we were dividing 9 by 4, this is the one I used in class today. So 9 divided by 4, that's going to equal, well, you know that's equal to 2. And it's also, that's 2, so 4 goes into 9. If we just, 2 times, 4 times 2 is 8. We have a remainder of 1. Okay? So if we have a remainder of 1, really, that means that it's 1 divided by 4. It's not just 2 plus 1. It's 2 plus 1 divided by 4. The other way that you can think about this is if I have 9 divided by 4, I know that I can take 4. Let me just think about this. So 9 is the same as 4 times 2 plus 1. So this is our divisor times our quotient plus our remainder, right? 4 times 2 plus 1 is 9, and 9 divided by 4 is 2 1/4. Okay, so if we're looking at this, p of x is our original polynomial function that we're dividing. It's like our 9. This divisor here is like our 4. Q of x it stands for quotient function. So this is our quotient, like that's the 2. That's the result of division, right? Plus your remainder divided by your divisor. So that's this remainder was 1 divided by your divisor. So this is like quotient form. The second one over here, we take our polynomial and it's going to equal our divisor times our quotient plus our remainder. Divisor times quotient plus remainder. So this is our corresponding statement. So let's go back to our first example and express our answer in both of these forms. Okay, so let's do quotient form first. So really quotient form is really the question, which is, all right, what is 2x cubed minus 3x squared minus x plus 2 divided by x minus 2? That's the question. And the answer is, okay, it's 2x squared plus x plus 1, that's our quotient, plus our remainder, which is plus 4, divided by our divisor, which is x minus 2. Okay? So quotient plus remainder divided by divisor. That's quotient form. Corresponding statement, do a different color. The corresponding statement is almost like a way of checking your answer. So you're saying that the polynomial 2x cubed minus 3x squared minus x plus 2, well, that's equal to the divisor x minus 2 times the quotient 2x squared plus x plus 1 plus the remainder plus 4. So technically, if I FOILed this out and added 4 to it, I should get this polynomial that I started with. Okay? So 2 different forms. You really do have to memorize those 2 forms. Okay, let's go try some more examples. So the only thing that this note says here is it's really important that you, number one, rearrange everything in descending order of powers, but also that if you are missing one of the exponents, so if they don't go down continuously, then you have to put a 0 placeholder in. So in this particular example, if you're dividing x cubed plus x minus 4 by something, you can see that you're missing the squared term, you would need to write in a placeholder squared term. And there can be more than one placeholder in a particular question. So if you were missing the x term as well, if you just had x cubed minus 4, you would need to put in 2 placeholders for the x squared term and the x term. Okay, so let's start here. It says divide the polynomials, express the result in quotient form, and then write the corresponding statement. And we're also, and we're going to state any restrictions as well. Oh, there it is. I couldn't see it. Okay, so let's get started here. So again, we're just going to write our x minus 1. And then we're going to make sure we rearrange this. So we're going to put 2x cubed first, minus 3x squared, plus 8x, minus 12. Okay, so I've got one of each exponent. That's good. All right, so let's kickstart this off. X divided into 2x cubed. That's 2x squared. So I'm going to take 2x squared and multiply it by x, and I get my first term here, 2x cubed. And then I take 2x squared and multiply it by negative 1. That's negative 2x squared. Now I have my 2 terms. I'm going to subtract them. This should disappear, which it does. Minus 3 minus minus 2 is minus x squared. Sorry, minus x squared. Bring down the 8x. I have 2 terms that I'm working with again, and then we're going to ask ourselves, what do I have to multiply x by to get minus x squared? And that, of course, is minus x. So when I multiply minus x by x, I get minus x squared, and minus x times minus 1 is plus x. Subtract again. Get rid of that, and then 8 minus 1x is 7x. Oopsie, I should be using red. Trying to have some color going here. I'm going to bring down that minus 12. I'm going to ask myself, what do I have to multiply x by to get 7x? Of course, you know the answer is plus 7. And so when I multiply 7 by x, I get 7x. And when I multiply 7 by negative 1, I get negative 7. I'm going to subtract one more time. And minus 12 minus minus 7 is minus 5. So the remainder up here, I can just put remainder minus 5, and I can put remainder minus 5 up here. And so I'm going to do the quotient form. That's going to be, I would write it in either way. It doesn't really matter. 2x cubed minus 3x squared plus 8x minus 12 is fine. Or the original form is fine too. Divided by x minus 1 is equal to the answer is the quotient, which is 2x squared minus x plus 7 minus 5 divided by x minus 1. So we don't put plus minus, right? It's plus the remainder, yes, but the remainder happens to be negative, so we just put minus 5 over x minus 1, the divisor. So this is quotient plus remainder divided by divisor. That's quotient form. Corresponding statement is we just start with our polynomial function, which in this case was 2x cubed minus 3x squared plus 8x minus 12 equals our divisor, x minus 1, times our quotient, which is 2x squared minus x plus 7, plus our remainder, in this case, minus 5. So if I expanded that out, FOILed it out, and then subtracted 5, I would end up with my original polynomial. Okay, restrictions. Well, these restrictions are easy to see when it's in quotient form. They're not so easy to see when it's written like this, but when you ask the question in this form, you can easily see that you've got a denominator here of x minus 1, and you know in math that you cannot divide by a negative number, so you want to put a restriction on your variable here that x cannot equal 1, because if x were equal to 1, 1 minus 1 is 0, and we would be dividing by 0, which is a no-no in math. Okay, but in the corresponding statement, the same is true. X can still not equal 1, even though you're not really seeing any dividing going on. Okay, but nonetheless, x cannot equal 1. Okay, let's do the last example. So the interesting thing about this one is that number one, we have a coefficient in front of our x of our divisor, which is interesting, and we have a term missing in our dividend, right? We don't have a squared term, so we're going to need to put a placeholder in. So let's get started. We're going to write 2x plus 1 divided into 4x cubed plus 0x squared plus 9x minus 12. Okay. So, start the same way that you started before. So, what are we going to multiply 2x by to get 4x cubed? And as I told you in class today, so it's 2x squared. What if this was a 3? You would have to come up with a number that you have to multiply 2 by to get 3. And of course that would be 3 halves. But you can get fractions in these questions. So be prepared. There are fraction questions in your homework, and you work with them the same way you would work with whole numbers. Okay, so I've got my 2x squared here. I'm going to multiply 2x squared by 2x, and hopefully that becomes 4x cubed. And 2x squared times 1 is plus 2x squared. Now I always have to have squareds subtracting squareds, otherwise we can't subtract them. If I had had this term here, 9x minus 2x squared, well, that can't simplify because these are not the same variable, right? That's why we needed the placeholder. So 0x squared minus 2x squared is minus 2x squared. Now we're going to, see what happens here. I used the wrong color, that's all. Okay, so now I'm going to bring down the 9x plus 9x. I'm going to ask myself, what do I multiply 2x by to get minus 2x squared? And the answer is minus x. 2x squared, minus x times 2x is minus 2x squared. And minus x times 1 is minus x. We're going to subtract again. 9x minus x gives me 10x. Bring down the negative 12. Now we're going to start the process over again. Last iteration here. 2x times what gives me 10x? And that's 5. And I'm just going to switch to Z. So I'm going to put plus 5 up here. And so then I'm going to take 5 times 2x. That should be 10x, and it is. And 5 times plus 1, which is 5. Subtract 1 last time. Minus 12 minus 5 is going to be minus 17. What color should I be in here? Sorry. Minus 17. So that is our remainder. And remainders can be negative, no problem. Okay, so if you're having difficulty coming up with these particular terms here, just another way of thinking of it is 4x cubed divided by 2x, if we were doing the very beginning. So if you I'll just do this up here. So 4x cubed divided by 2x. You could divide terms that don't have the same variables, but you can't subtract them. So in this case, 4 divided by 2 would be 2. And x cubed divided by x, remember our rules for dividing powers with the same base, you subtract the exponent, right? So that's how we ended up with that 2x squared. Okay, so if you're having difficulty, you can go back to those grade 9 rules, and that will work every time for you. Okay, let's just finish this off with the quotient form then. So quotient form is really just, what's the question? I would go back to the original form without the 0x squared. So that's this divided by 2x plus 1 is going to equal the quotient, which is 4x cubed plus 9x minus 12 plus our remainder, but we don't do plus minus 17, we would just do minus 17 divided by our divisor. And I'm going to throw in a restriction there. X cannot equal negative 1/2. I'm going to run out of room. Where is that coming from? It's coming from this divisor. If you don't know how to figure out the restriction, just set this equal to 0. Rearrange and solve or isolate for x. So x is equal to a negative 1/2 when this whole thing is equal to 0. So that is our restriction. X cannot equal negative 1/2 because it will make this 0. All right, and last but not least, corresponding form. No, or corresponding statement, I should say, is, okay, take your polynomial, 4x cubed plus 9x minus 12, and that's going to equal your divisor, 2x plus 1, times your quotient, which is, sorry, that didn't work out. I'll repeat that, 2x squared minus x. I think I'll just erase that for good measure. Hang on. Let's just start over. All right, so I've got my divisor there, 2x plus 1 times 2x squared minus x plus 5 plus my remainder. Close that bracket and plus, whoopsie, I could do this, but that's not nice and neat. So instead, I'm going to put minus 17. And again, I'm just going to erase that. Back here, sorry. And that's minus 17. Okay? All right, that's the corresponding statement. And of course, I'm going to include, but I'm running out of room on that line. So x cannot equal negative 1/2. Okay, that's it for the lesson. If you do have access to your Consolidate, please do it. And if you do need any help with this, because I know it is difficult, please see me at lunch. Thanks a lot.